Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 17 part B. This is question 17 part B from the specimen paper of the specimen paper of the 2025 new syllabus for the Cambridge 0580 paper 2 extended, and this is the non-calculator paper. This question here is about similarity. I've answered it separately from part A because it's, you know, a slightly different topic. I want to save it in a different heading in my playlists, but you can also find part A by looking at the playlist for the paper here, which will be in the linked at the top here. Also at the beginning of this video you'll see a link on the card on the top. Anyway, so here it says in the diagram, triangle ADX, which is this triangle here, is similar to the triangle BCX, which is this small triangle here. So the triangles that they are trying to point us towards are this triangle here, ADX, which is, I'll just highlight it a little bit. That's ADX, and that's similar to the triangle BCX. So BCX. So those two triangles are similar triangles. Okay, and they told us that they're similar. They could have told us to prove that they're similar because we have enough information from this diagram to prove it, and from what we've done before. But they're not asking us to do that. They're telling us that they're similar. So what I like to do is, when I'm dealing with similarity, I take these two triangles and I'll draw them outside of the box, outside of the, get rid of this. Okay, outside of the diagram. So this is the triangle. And let me just keep everything clear. That's A. Get the pen back. That's A D X. A D X. That's the triangle here that I've just drawn, right? So I know that this angle is 34. We learned that in the earlier part of the question. So this is the angle over there, 34 degrees. And we know that it's similar to the triangle BCX. So I'm going to take BCX, but I'm going to draw it. So I'm going to copy this triangle here, and I'm going to paste it here, and I'm going to just make it smaller. Okay, so I'm drawing it with the same orientation as we have over as this other triangle, so we can compare them. So this is this triangle drawn with the same orientation. Now, how do I know what letters go where? Well, I can mark this angle as 34 degrees. All right, so I know that that's going to be where C is, and I know that this is X. Okay, so that's going to be the same as that X over there. They're the same point. And then the other one must be B. Okay, so I can mark this as B. So now I have all of the corresponding points marked. Now I can put in the values of the lengths. So BC is 4.5 centimeters. AD is 9 centimeters, so that's there. And CX, which is this, is 3.3 centimeters. And we've got to find what XD is. We've got to find what this length is over here. Okay, let's call this small x. Right, so we can use similarity here. Very simple. We can see just by looking at the diagram that this length is double that length. 4.5 times 2 gives you 9. So this length, because they're similar, the ratio of the lengths is the same. So this length must be 2 times 3.3. So x must be 2 times 3.3, which is 6.6 centimeters. We could do it also by, using some sort of proportion. We say x over 3.3 is the same ratio as 9 over 4.5, which is going to be 2 times 3.3. So x is going to be 6.6. Or we can even say that, okay, we're going to take the length that we know corresponding to the one we're trying to find. So we can say x is equal to, this is the length that we know corresponding to the length we're trying to find, multiplied by, then we say, okay, we want to find the length on the bigger triangle. So I've got to take a pair of values which are in the same position relative to each other, but I've got to take the bigger over the smaller. Of course, that will give us the same answer, 6.6. So there's different ways we can think about it. We can say, okay, we know the scale factor is equal to 2, and we're going from bigger to smaller to bigger, and we can work it out that way. So there's lots of different ways of dealing with this type of question. All right, pretty simple. And there's the answer to part B, which is got something to do with similarity. There's also another question later on in this paper. I don't know if it's the next one I'll answer in this paper. No, it's not. Okay, so it's further on in this paper. So I'm going to answer that under similarity as well. Okay, that's to do with areas and I think areas and similarity. Okay, so in that particular question, you'll notice that this type of method would be a kind of an easier way of dealing with it, or even these two, both of them. We'll see that when we get to it. So that concludes question number, was it 17? Yep, from this paper, 17A and B done. B is on a separate video. You can subscribe. You can subscribe to the channel by clicking on this link. You can see the rest of the specimen paper questions, including part A of this question, from the link over here. This link will take you to questions which are dealing with the topic of similarity from this new syllabus, and you can also find the older questions on similarity. They're basically the same, except for everything's done now by nothing in this new syllabus is done by calculator. So these will be mostly answered using the calculator. In this new syllabus questions, we won't use a calculator. So yeah, thank you for watching and see you soon.